Okay, for today, I'm going to start with a review of 2 days ago. You got a problem like this, x plus 8 over x minus 9. The research shows if I tell you how to do the vertical and the horizontal, you actually won't remember it as well as if I ask you to just try to remember which of these is the x equals thing, which of them is the y equal thing, and try to remember it yourself. Okay? If you can't, I'll show you how in a minute. But how do you get the vertical asymptotes? And how do you get the horizontals? It's 2 days old. Pausing while you try those. Okay, so the most common mistake here is thinking that the vertical asymptotes come from here. I know it's tempting to say that -8 is like important. It's not. It does not give you the vertical asymptote. What does give you the vertical asymptote is that. So it should be x equals 9. Raise your hand if you had that as your vertical. Good. The horizontal is the deal where you put in the 1,000 trick. And again, it's not really 1,000. It's a million. It's a billion. Okay. And so for the horizontals, isn't 1,000 plus 8 pretty much just 1,000? If we're kind of saying close to, and then this is close to 1,000 also. So that's pretty much 1,000 over 1,000, which is pretty much y equals 1. Who had y equals 1 before I said it? Awesome. Then you remember verticals and horizontals. All right. Next thing we talked about was, what if we had two functions, f of x and g of x? And here, write these down. F of x is 1 over x minus 12. I hope you can recognize right away that's got restrictions. So what's the domain of f? Put it right underneath f of x. Get used to that for this whole unit. Whenever you get a function, just right away, you're going to be starting to write down the domain. And sometimes the range. In this case, just the domain. G of x is x squared minus 4. It's also got a domain. Everything has a domain. Domain means what can you safely feed the function. So a common mistake answer is just to say, well, you can't feed it peanuts, or you can't feed it a 12. What you have to say is, you can feed it everything except a 12. So I put it on a number line and do it this way. You've got to list what it can safely eat. You can't just say not equal to a 12. No, it could eat everything except a 12. Okay, and this one, well, I could make a number line for it, but it's probably faster to just go all reals. It would have been a number line with everything shaded. Are you with me so far? Raise your hand if you are. You feel like you get this. Okay, good. Now we're going to do f eats g. F of g of x. Again, I'm tempted to just show you how to do it, but I hope you remember it. You stretching yourself to remember makes it stick more. Give it a shot. Make the f eat the g function. And then figure out the new domain. And I know some of you are going to forget something important. Be careful. Pausing while you give that a shot. I'm going to remind you how that worked. This was 1 over x minus 12, but I'm putting an empty parentheses. That's what I recommend, where the x was. And then you're going to make it eat the x squared minus 4. And then you should simplify it. If you haven't already, simplify that. Some people get freaked out by those parentheses, but there's nothing you can do in them. And there's no negative being distributed into the parentheses. So you can just drop them in this case. Sometimes parentheses matter a lot. Other times they can just be dropped. How many of you got 1 over x squared minus 16? Raise your hand if you did. Cool. Do you get that has new restrictions that you didn't used to have? Then write the new domain for this thing. I'd use a number line, personally. I'm telling you, the number line's the way to go. Then, if you need interval, you put that underneath that. A lot of kids get stubborn and they're like, I'm not making a number line. Okay, fine. You're going to get these wrong on the test. telling you. Because here's a -4, and here's a 4, and everything else works. And that's the wrong final answer. But I thought that's how you do this. Who remembered the thing? Yes?
You have to do the parent function still.
This has to be included too. It also can't be 12. And try to do that with just interval notation. Pain in the butt. So here it's easy. You just pop on a 12 and say it can't be 12. And then let it keep going after that. Now, can you write this in interval notation at the end? Sure. But start with the number line. And there's your final answer. Why did we have to include that parent thing? It's just like when I went to the doctor the other day. They didn't just say, how do you feel? What makes you, sick right now? Like what's causing, what's your current health issues? They said, did your mom or dad have a history of heart attacks, cancer, strokes, etc.? They asked me about the parents because they can cause issues for the children later. So you have to go back to the parent restrictions, and those have to be included in your final answer. And then if you want interval notation, it will be -infinity to -4. You do not have to write this. I just know some people like it. -4 to 4, 4 to 12, and 12 to infinity. And then I got to go back and put a little u in between every one of them. Personally, I think the number line's way easier. And when you try to throw in, oh, by the way, 12 doesn't work, it's really hard to do that in interval notation. But you can do it if you really want to. I'm not going to grade you wrong if you give me this answer. But I really think that the number line is so much easier. I know where we're headed to and the problems we're going to do in the future. All right. Brutal honesty. How many of you would have had that right without me? All right, that's less than half the class. We're going to do one more like that then, because that's yesterday's stuff. And less than half the class got it right, so we'll try one more. F of x equals 1 over x minus 4. G of x equals x squared. What's f of g of x and its domain? Winston, tell me what you think. What's the domain of the original f? D of f. Personally, I like to use number lines. What's the one thing it can't be? Good, and that's what you do. Anything but 4. What's the domain of g, Winston? Good. When you make the f eat the g, Tate, what do you get? Here's f. Yep. Yep. Okay. Now, what's its domain? Well, you do a number line. And what are the 2 things here that it can't eat? Tate?
Positive, -2, and 4.
Ooh, and you remembered that this also has to be included. So wait, first I highlight this and say it can eat everything except -2 and 2, But then I remember back to the parent weakness of that 4, and I go, also can't be 4, but can be everything else. There you go. That's a good answer. Who had that before I said it? Okay, awesome. Now I need to teach you a couple things about inverses, and then you have homework about inverses. It's a whole new topic, completely different. So first off, you got to know what a function is to even understand whether something has an inverse. So here's a function. That's considered the exponential function. It's like exponential growth. Does that pass the vertical line test? Do you remember that deal? If you draw a vertical line through it, it'll only hit once, right? So this passes the vertical line test, therefore it's a function. All right. Would this blue one pass the vertical line test? No. So it's not a function. But now you have to learn about something called the horizontal line test. This one, that blue one, this one may not be a function itself, but it passes the horizontal line test. That means its inverse will be a function. So this blue thing is not a function, but it passes the horizontal line test, so its inverse will be a function. All right, now we got to understand what the heck is an inverse. You know what the inverse of plus is? Minus. What's the inverse of squared? Square root. What's the inverse of multiply? Divide. Okay, good. So if it was that simple, I mean, we'd be in 4th grade here. We have an equation that looks like this, and we're going to find the inverse of it. So it's got a minus 4, we're going to use a plus 4. It's got a times 3, we're going to use a divide 3. And then we're going to end up getting a function that's the inverse. This one is a function. I know, because if I wanted to graph it quick, I know its y-intercept is -4 and its slope is 3, and you're supposed to know that. You know, this is one of those like basics. You're supposed to be like, oh, that's the slope, that's the y-intercept, this is easy. I know that from the first 20. It's on the first 20. And people that don't know the first 20 might be like, I wouldn't have known how to graph that. But you guys should be able to graph that. So if I ask you to tell me its domain and range, if you just make a quick sketch like this, and you just kind of like, it kind of is a line like this. Now can you tell me the domain and range? The domain is easy. There's no restrictions. Look at it. There's no square roots. There's no denominator. But the range, well, the range is just up and down. Please write D and R and tell me the domain and range of this function. Remember, domain is what the x's can be. How far it goes left and right, because that's x. Do you agree it goes all reals, left, right? Good. How about up, down? Also all reals. See why I gave you that shortcut? It saves me like 10 keystrokes every time I'd have to type parentheses, negative infinity, comma, infinity, parentheses. All right. Cool. Now, why do we care so much about the range all of a sudden? Because when we do an inverse, like I said, the minus becomes a plus, the times becomes a divide, and the domain becomes the range. Everything's like opposite world. You know, inverse, you have inverse of plus is minus, inverse of times is divide. The domain becomes the range of the new function. So I'm going to do this first one for you. I take the original function, but I'm going to do something to it. See if you can catch what I did. I took the original function, and what did I do? Can somebody verbalize what I just did? Change the x into y, and change the y into x. You know, everything's like opposite world. Yes means no, no means yes. X turns into y, y turns into x. Domain becomes the range, range becomes the domain. Everything gets switched, flip-flopped. Plus, minus, those are inverses. They're called additive inverses. All right, so now, this is the inverse, but on the test, I'm going to have it where you have to solve it because it's a little too easy to just switch x and y. And usually we solve them for y. So you might be like, but Mr. Server, you haven't even changed -4 to +4, and you haven't changed -3 to divide 3. We will. So this was the original, and this is the inverse. Questions? Do you have questions so far? Okay. So I've got my original, I got my inverse, but I got to solve my inverse. And so I'm going to add 4 to both sides. And now I have x plus 4 equals 3y. Now I'm going to divide by 3 on both sides. And now I'm going to rewrite this. Y equals x plus 4 over 3. Didn't I tell you that the minus was going to turn into a plus? And the fact that there's a times 3 here means we're going to use a divide 3 there. See what I mean? So if you get an equation from me, you figure out its domain and range first, and you might not understand why I did that. And I'll tell you in a minute. But then you just switch the x and the y around. X becomes y, and y becomes x. You know, the y in the front becomes an x. The x that right after the 3 there becomes a y. And then you just solve it for y. And then you have to tell the domain and range of this. If I had to graph this, I would really be hating life, because that sucks to graph. It would take like 20 minutes. So I don't have to, because I already told you how to do it. Who's got a short-term memory? How do you get the domain and range of this? You flip them around. The domain becomes the range, which is all reals, and the range becomes the domain. All reals again. This was kind of a boring one because the domain and range were just both all real. We're going to do another one in a second. Okay. New problem. Y equals square root of x minus 5. If you have forgotten how to graph this, I'm going to be a little despondent, but you got a square root graph that kind of looks like a ramp, and then it's been moved which way? Up 5? Which way? Right 5. So sketch this. This is a square root graph that's been moved right 5. Why am I sketching the graph? Because then you'll be able to tell me the domain and range. Why do I need to tell you the domain and range? Because we're going to find the inverse. And to do that, we got to switch the domain and range around for the inverse. Do you get how pre-calc is hard? You have to remember everything I've taught you and put it all together in one problem. Like if you can't do the graph now, then you won't be able to do the range. If you can't do the domain and range, then you won't be able to do the domain and range of the inverse. So like I got to teach you a new thing, and you have to remember all the other stuff. That's why pre-calc's hard. Got so many parts to it. And it could be harder, let me tell you. In honors, what we've done in the last 3 days would probably been maybe 2 days. 3 days down to 2 days. It just goes way faster and deeper too. And the tests are harder. So you can be happy where this is as hard as it is. It could be way worse. All right, did you remember that it was a ramp that was moved to the right 5? Raise your hand if you sketched that properly. Okay, good. Now, can you tell the domain and range? My gut says you should probably say 5, 0 here, so you remember those numbers are included in your domain and your range. Would you please just check the domain and range with the kid next to you? See, just finish it first, and then see if they have the same domain and range as you. Amber, did you check with anybody yet? Check with somebody. Lux, what do you say? What's the domain?
Domain is that's a closed interval from f to or 5 to infinity.
There we go. 5 to infinity.
And
Yes.
range is 0 to infinity.
0 to infinity with a bracket. Nice. Okay, you guys have that? You got the same thing? Yes? Okay, good. All right, so that's just all stuff we're already supposed to know. Now, what's the new thing? Inverse. So you take this and you rewrite it as x equals square root of y minus 5. And you can't just leave it that way. That'd be too easy, frankly. That would make it just like a 5th grade thing. But now you got to solve it. How are you going to solve it? Square both sides. Very good. We had problems like this where you had to get rid of square roots before, and you squared. So now we got x squared equals y minus 5, because those were inverses, you know? Square root and squared, they're inverses. Bodie, final step to get y alone.
Plus 5.
Yes. X squared plus 5. And I like to put the y on the left, but you don't have to. You could have just said equals y and it would have been okay. On my original one, I had a square root. On my new one, I have a squared. See that? On my original one, I had a minus 5. On my new one, I have a plus 5. You see how it kind of makes sense? Those are inverses. Now, should I graph it? No. Even though this isn't that hard to graph, your domain and range of this inverse should just come from here. The domain becomes the range. Go ahead and put them in the right spots. You've made the inverse. Now what's the domain and range of that inverse? Hudson, the domain on the top goes down and becomes the range on the bottom, right? So what should I put down here? What are these two answers, Hudson? Correct, because it came from the range. 5 to infinity. Now, it is true that if I graphed this, that this would have actually been the right range, but it would not have been the right domain. So you might be like, but that doesn't make any sense. Trust that you can reverse these two, and just trust that's your actual answer. You don't want to graph this and try to find the domain and range from that. You don't want to do that. It would mess you up. Because this, you would have thought your domain would have been all reals. Because if you graphed that, it'd be a parabola, and you'd think the domain was everything. So trust me. Bring the domain down and become the range, and bring the range down to become the domain. This overrules what the graph looks like. I know, that's hard to process. But it's because it came from this function, where do you get this function? We couldn't use negative numbers in it. In this original function, we couldn't use negatives. That means when we go down and make this new one, it has a different domain than you would think. So just trust the domain and range reverse. The really common mistake is kids go, oh, so I'm going to draw my picture now, and I'm going to look at what this graph looks like, and it looks like this, and so now I do my domain and range. Nope, that doesn't work on the inverses. On the inverses, you have to get that answer from the original. Okay, so here's what your homework kind of looks like. Don't open it yet, but in a second. They're going to give you a picture, and they're going to go like, is this a function? Yeah, passes the what? Vertical line test. Then you got to ask, will its inverse be a function? And the way you can tell, horizontal line test. This fails a horizontal line test. So will this guy's inverse be a function? No. So the vertical line tests, is it a function? The horizontal line test is saying, if I make its inverse, will that be a function? So this one was a function, but its inverse would not be a function. Okay. The next part of the test, they give you this weird little symbol, and I want you to know what it means. Please, from context clues, take a wild guess what that means. It's a word that starts with I. Inverse. Yes. That's the symbol for inverse. When they want you to do that, they're saying find the inverse. Okay. And then they're going to want you to do the domain and range. So again, always make a little sketch of the original one, and you'll be able to see its domain and range. Then you can know to reverse them to find the domain and range of the inverse. I know it's a lot, but I think you can handle it. So here we go. Find the homework for today. I'll tell you which ones to skip. I'll start it with you. And it looks like this to start with. By practicing this, we'll make it stick. Those of you that aren't doing your practice at night because you're not doing homework, you're probably getting a whole grade lower than you would. And that's on you, especially if I post the keys. All right, got it pulled up. Tate, is this first one a function? Correct. Now, the second question, though, is still a valid question, which is, does the relation, which is another name for something that's a graph but not a function, does that have an inverse that is a function? So really what they're saying is, try the horizontal line test. It passes the horizontal line test, doesn't it? Never touches twice, right? So the part A answer was no, it's not a function. The part B answer is pass the vertical line test, so yes. Or sorry, the horizontal line test. It passed the horizontal line test. So yes, the relation has an inverse that is a function. Part A, is this a function? Yes. Part B, when you do the horizontal line test, it answers whether this thing has an inverse that's a function. What do you say? No, because it doesn't pass the horizontal line test. So you could simplify this as much as to say the first part A is just, does it pass a vertical line test? And the part B is, does it pass a horizontal line test? Here's our first one. Passes the vertical and passes the horizontal, see? So A, it's a function. Yes, it's a function. B, yeah, its inverse is also a function. I think you've got the idea. You can do number 4 yourself. Number 5, they want you to, they don't say to graph it, but I'm telling you, sketch it and then tell its domain and range from the sketch. Because why? Because I can't even do the range without a sketch. I'm the math teacher. You'll need a sketch to get the range. You might be able to do the domain because I can look at this and say, oh, no restrictions. Oh, that, okay, you're right. But will you be able to do the range? Once I draw this, start with -6, slope of 3, then I can tell its domain and range like almost instantly. Domain all reals, range all reals. Cool. Is that it? No, that's just the start. Now, you flip-flop the x and the y. Remember, f of x is like y, right? So that's really like y. So now I'm going to flip-flop my x and my y. X equals 3y minus 6. And then you solve it for x. But remember, when you're done, don't graph the final answer. Do the reverse trick. The domain comes from the range. And the range comes from the domain. Okay, I got you started on that one. If you need more help, I'll happily help you. I'd like you to skip problems 7 and 8. Number 9, again, you make a sketch, and oh, it's a ramp that's been moved to the right 3, and it won't be that hard then to get your domain and range from that. So do 9 and 10. Do you remember what the x to the third graph looks like? If you forgot, I'm just going to remind you quick. X to the third looks like that. So you can tell the domain and range from that. I think 13 is going farther than we need you to. And 14 is totally review, so we'll skip 13 and 14. The 1-to-1 function means the perfect function that passes both the vertical and the horizontal line test. You may cross off the part about sketch the graph of the inverse. I might teach you that a different day. And then stop right there. Hard stop, don't do any more problems. That's enough. Do you agree that I cut your assignment down? And now it's doable, and that means you actually need to do it. That's the other reason I feel like if you don't do your homework in a class where the teacher has cut it down to be a very reasonable size, then you're slacking too much. There's times when I know you have 2 AP classes and they demand your full attention. I get that. But if you're not doing your homework regularly, please get back on the horse. You can do this. And that's all I have for the video for today.